Hey guys, just to give you an idea about how much noise it generates, just take a look at this LED over here. You can see when the switch is off, as I said, the switch is having some issue. That's why this LED is on but the motor is off, because the LED is getting power directly from the AC input. So you can see the blue light in here. It glows perfectly fine. Now as soon as I move around the switch, you can see the blue light gets a lot of flickering. Let me just show you that. I'm going to move the switch. So you guys can see how even this LED, you can see how this LED is getting affected by the noise. See that power bank LED and this one over here. That is the reason, guys. This is why I said this. This is the reason why I said you better provide a separate capacitor at the motor side and at the input side as well, just like I have shown you in the schematic. And this is the same reason why I said do not follow what the other YouTubers are saying, like connect it straight to the motor. Now even with all these extra capacitors and bits and pieces, you can still see how much noise the device is actually sending back to the power source. This power bank is actually getting a lot of noise back from the motor itself, and you guys have visually seen it from the variation of the LED light intensity over here and even this LED over here as well. So do not connect your power bank straight to your any motor load. It's going to affect it in the longer run. Although it greatly depends on how good your power bank really is, how good it is in withstanding all this noise. But generally I'll say avoid connecting inductive loads to your power bank. It's not good for their longer, healthier life. So that's it for today's video. Thanks for watching and see you in another episode.